Hey everyone, and welcome back to your daily dose of what's trending in tech. Yesterday, Hacker News was absolutely buzzing with some fascinating discussions. We reviewed 24 stories and picked the top 5 that really got the community talking. We've got everything from a philosophical rebellion against complex system design to the surprising mathematics of onion cutting. We'll explore why some developers are deliberately building things that don't scale, dive into the shadowy world of payment processing monopolies, and check out a potential breakthrough in dental care that involves hair. Yeah, you heard that right. What I love about today's selection is how it captures this ongoing tension in tech between complexity and simplicity, between theoretical optimization and practical reality. So let's jump right in with a story that really struck a nerve, the case for boring system design. All right, let's dive into something that really struck a chord with the Hacker News community: good system design. This piece got over 750 points and sparked more than 300 comments. And honestly, I can see why. It's basically calling out the entire tech industry for our obsession with complexity. So here's the provocative thesis. Good system design should be boring. Not impressive, not clever, just boring. The author argues that if you're looking at a system architecture and thinking, wow, that's impressive with all those distributed consensus algorithms and event sourcing patterns, you're probably looking at a bad design. Instead, good design makes you think things like, that was easier than I expected, or I literally never have to think about this part anymore. And you know what? This really resonates with me. How many times have we seen teams adopt microservices because it's the right thing to do, only to end up with a distributed monolith that's 10 times harder to debug? The author's point is that those complex, impressive-looking systems with CQRS, fancy message queues, and clever tricks, they're often just band-aids covering up fundamental bad decisions. What's fascinating is how the community discussion revealed this huge disconnect between what we know is right and what actually happens in the real world. Multiple commenters pointed out that in system design interviews, if you propose a simple solution, like, say, just using a single Postgres database with proper indexing, you'll often get dinged for not being senior enough. The expectation is that you'll throw in Kafka, maybe some Redis, definitely microservices, even when the problem doesn't call for it. One commenter put it perfectly. They said, interviews reward unnecessary complexity, and that's creating this whole generation of engineers who think complex equals good. But here is where it gets interesting. Not everyone agreed with the article's specifics. There was this heated debate about database ownership that I found really compelling. The article suggests each service should own its database rights, but a commenter named Motorist pushed back hard on this. They argued that sometimes sharing database access between services is actually simpler than creating all these custom API layers with their own authentication, authorization, and transaction handling. And honestly, they might have a point. Sometimes the correct architectural pattern introduces more complexity than the problem it's trying to solve. Another commenter, Alphazard, took an even broader swing at the whole premise. They said the article misses the forest for the trees by focusing on internal architecture instead of the actual user-facing design. In their view, whether you use microservices or a monolith matters way less than whether your interface actually solves the user's problem elegantly. And yeah, that's fair too. What really stood out to me in the discussion was how many people had war stories about simple systems that just worked for years without anyone touching them. These boring, underwhelming designs that nobody ever presented at conferences because there's nothing sexy about them. Meanwhile, the clever, complex systems, those are the ones people were constantly firefighting, constantly explaining to new team members, constantly re-architecting. The author makes this distinction between system design and software design that I think is crucial. When you're writing code, you're dealing with functions and classes. But system design, you're assembling app servers, databases, caches, queues. These are fundamentally different building blocks with different constraints. A clever algorithm might be perfect in code, but a clever architecture at the system level, that's often where things go sideways. You know what this reminds me of? That old engineering adage, anyone can build a bridge that stands. It takes an engineer to build a bridge that barely stands. Except in software, we've somehow inverted this. We celebrate the complex, barely standing bridges and overlook the simple ones that just work. The discussion also touched on something really important. Context matters enormously. Several commenters criticized both the article and general system design advice for being too absolute. What works for a 5-person startup is different from what works for Google. A system handling 10 requests per second has different needs than one handling 10,000. And yet, we often apply the same architectural patterns regardless of context, usually whatever's trending on tech Twitter that week. There's this underlying tension here between engineering culture and engineering reality. We've created an environment where complexity is rewarded in interviews, in performance reviews, in conference talks. But the actual best solutions, the ones that last and scale and don't wake you up at 3 a.m., those are often the boring ones that nobody wants to talk about. Speaking of embracing simplicity and pushing back against unnecessary complexity, story 2, do things that don't scale and then don't scale. Now here's a story that really caught my eye on Hacker News today. Do things that don't scale and then don't scale. And yes, you heard that right. It's not about eventually scaling, it's about staying small on purpose. So this piece has sparked quite the debate with almost 400 points and over 150 comments. And I think it touches on something really fundamental about how we think about building software today. The author's main argument is that with AI coding assistants like Cursor and GPT, we've hit this inflection point where you can build a fully functional app in an evening instead of burning through multiple weekends. And here's the kicker. They're saying we should use this newfound power to build things that deliberately stay small. Let me give you a concrete example from the article that I absolutely love. The author built something called Postcard Mailer, which automatically took their Instagram photos and mailed them as physical postcards to their mom. That's it. That's the whole product. No pricing page, no growth strategy, no pitch deck for VCs, just a thing that makes their mom happy. And you know what? That's kind of beautiful. But here's where it gets really interesting. The author runs this 100-person Slack workspace, and they make this provocative claim that if it grew to, say, 1,000 people, it would actually get worse. The intimacy would evaporate, the vibe would break. They're essentially arguing that some things are valuable precisely because they're small, and growth would literally destroy what makes them special. Now, the Hacker News crowd, they're having a field day with this one. There's this whole contingent of commenters who are basically saying, wait a minute, what does AI have to do with any of this? We've been building weekend projects and personal tools since forever. And honestly, they have a point. One commenter, Ulu Dog, really went after this idea, saying people have been cranking out small projects long before ChatGPT came along. They argue it's really cloud services and platforms like Heroku or Vercel that made hosting trivial, not AI. But I think there's something more nuanced happening here. Yes, weekend projects have always existed, but the author's arguing that the barrier has dropped so dramatically that the entire calculus has changed. It's not just that you can build things faster, it's that you can build things so fast that you don't even need to justify the time investment anymore. Want a custom tool that only you and your 3 friends will use? Go for it. Takes an evening, not a month. There's this fascinating discussion in the comments about social dynamics and scale. Multiple people brought up how Facebook was actually better when it was just college students, how small communities have this magic that disappears when everyone and their grandmother joins. One commenter mentioned how they've watched multiple online communities go through this exact pattern. They start intimate and valuable, grow because they're valuable, and then the growth kills exactly what made them valuable. What really resonates with me is this idea of home-cooked apps. that one commenter mentioned. Just like you might cook a meal for your family that you'd never serve in a restaurant, maybe we should be building more software that's just for us and our immediate circle. Not everything needs to be a startup. Not everything needs a business model. Sometimes things can just be useful to 5 people, and that's enough. And look, I get the skeptics. The original do things that don't scale advice from Paul Graham was specifically for startup founders trying to get traction before building scalable systems. This is almost the opposite. It's saying do things that don't scale and then just keep them that way. It's almost subversive in the current tech climate where everything's about growth metrics and user acquisition. But maybe that's exactly why this resonated so much with the HN crowd. We're all exhausted by the growth at all costs mentality. We've seen enough good things ruined by trying to serve everyone instead of serving someone. And if AI tools really have made it trivial to build custom solutions, well, maybe it's time to embrace building small, intentional things that do exactly what we need them to do, for exactly the people who need them. The question isn't really whether AI enabled this. People will debate that forever. The question is, what small, unscalable thing could you build this weekend that would make your life or someone else's just a little bit better? And more importantly, can you resist the urge to turn it into the next unicorn? Now, speaking of theoretical optimization versus practical reality, let me tell you about someone who took mathematical analysis to a whole new level. All right, so here's something completely different. Dicing an onion the mathematically optimal way. Yeah, you heard that right. Someone actually sat down and did the math on how to cut an onion. And it sparked quite the debate on Hacker News with over 230 points and 80 comments. Now, I know what you're thinking. Who has time to mathematically optimize their onion cutting? But honestly, this is exactly the kind of wonderfully nerdy deep dive that I love about the tech community. Someone looked at a mundane kitchen task and thought, there's got to be a better way to do this, and then actually ran the numbers. The article apparently dives into calculating the optimal angles and cuts to achieve the most uniform dice possible. And here's where it gets interesting. The community response was this perfect mix of appreciation and skepticism. Like, sure, we can calculate the theoretically perfect way to dice an onion, but should we? One commenter, Fiorin, came in hot with some serious criticism. They argued that the whole analysis missed what they considered better solutions, like not cutting all the way through on alternating cuts. They basically said, you can't claim mathematical optimality when you haven't even explored all the options. And honestly, that's a fair point. It's like optimizing a sorting algorithm but only looking at bubble sort variations. But what really caught my attention was this broader philosophical debate that emerged. Several people pointed out that perfect uniformity might not even be the goal here. Think about it. When you're cooking at home, what really matters? Is it that every single piece is exactly the same size? Or is it just that you don't have any huge chunks that won't cook properly? One person mentioned that the mathematically optimal approach only improved the standard deviation by about 4% over traditional techniques and required these complicated angles that would be nearly impossible to execute consistently in a real kitchen. The practical cooks in the comments had a field day with this. People were sharing all sorts of techniques, quarter cuts, multiple horizontal cuts, even street vendor methods. It's like, here we have this mathematical analysis, and then real people are like, yeah, but have you tried just doing it this way? There's this user, Fume, who basically dismissed the whole thing, saying that complexity isn't worth a 4% improvement. And you know what? They might have a point. This reminds me of that classic engineering problem where you can spend 80% of your time optimizing for that last 20% of performance, except here it's more like 95% of your effort for 4% improvement. But here's the thing, and this is what I love about these kinds of discussions. Even if the practical application is limited, the exercise itself is valuable. It's about approaching everyday problems with analytical thinking. Sure, maybe you won't use trigonometry next time you're making dinner, but the mindset of questioning and optimizing, that's what drives innovation. And let's be honest, this is peak hacker news content, right? Taking something completely ordinary and applying rigorous mathematical analysis to it. It's the same spirit that leads to people writing compilers in brainfuck or calculating the optimal strategy for Monopoly. Is it necessary? No. Is it fascinating? Absolutely. The comment section really became this interesting microcosm of the eternal struggle between theory and practice. You've got the mathematicians defending the purity of the optimization problem, the pragmatists pointing out real-world constraints, and then the cooking enthusiasts just wanting to share their grandma's technique that works perfectly fine, thank you very much. What strikes me is how this simple vegetable became a battleground for different philosophies of problem solving. Do we optimize for mathematical perfection, for practical efficiency, for ease of execution? Or maybe, just maybe, the current way of doing things is actually fine, and not everything needs to be disrupted. Though I've got to say, if someone wants to invent a kitchen gadget that perfectly dices onions using these mathematical principles, I'd probably buy it. Not because I need it, but because, well, it's mathematically optimal. How could I resist? Speaking of innovations that promise to solve everyday problems, let's shift gears to something that could actually impact millions of people's daily routines. But here's where it gets interesting. This isn't claiming to regrow enamel from scratch. It's more like creating a biological patch that integrates with what's already there. The keratin apparently seals up those exposed nerve channels that cause sensitivity, while also creating this mineral-dense layer that protects the tooth. It's addressing both the structural problem and the pain problem at once. The comment section turned into this fascinating debate about what repair even means when it comes to teeth. Several users pointed out that we already have products that do something similar. There's nanohydroxyapatite toothpaste that's huge in Japan, and something called Novamin or Bioglass that's been around for years. One commenter, Buyback was pretty blunt about it. They're saying this is just marketing spin for another protective coating, not the revolutionary repair mechanism it's being sold as. But you know what really struck me about this story? The sustainability angle that nobody's really talking about. We're potentially taking a waste product, hair from salons, wool from sheep, and turning it into something that could help billions of people maintain their dental health. That's the kind of circular economy thinking that gets me excited, even if the dental benefits turn out to be more modest than claimed. The frustration in the comments is palpable, though, and I get it. There's this pattern in dental research where everything sounds amazing in the press release, but then it either never makes it to market, or when it does, it's way less impressive than promised. One commenter mentioned they've been following tooth regeneration news for years, and nothing. Still drilling and filling, same as always. What's different here, maybe, is that they're not claiming to regrow teeth or perform miracles. They're saying keratin can create a protective barrier that's better than what we currently have. It's incremental improvement rather than revolution, which honestly might mean it actually has a chance of making it to market. The researchers are being pretty specific about the mechanism, too. It's not just slapping some keratin on your teeth and calling it a day. The protein forms this specific structure when it interacts with calcium and phosphate in your saliva, creating something that's chemically and structurally similar to actual enamel. That's pretty clever, using your body's own minerals to build the protective layer. Still, the skeptics in the comments raise good questions. Why is this better than existing alternatives? If nanohydroxyapatite already does something similar and is available right now, why wait 3 years for a keratin version? Is this solving a problem that's already been solved, just with better marketing? I think what we're seeing here is the collision between scientific possibility and commercial reality. The science might be solid. Keratin probably can form protective layers on teeth. But whether that translates into a product that's actually better than what we have, affordable enough for regular use, and effective enough to justify switching from fluoride, that's a whole different set of questions. And based on the comment thread, the hacker news community has seen this movie before, and they know how it usually ends. Now, from innovations that might make it to market someday, let's talk about a market that's already here, but controlled by forces most of us never even think about. Story 4, making your own merchant service provider. All right, so our next story really pulls back the curtain on something most of us never think about: making your own merchant service provider. This one got 238 points and 150 comments on Hacker News. And honestly, after reading through it, I can see why people are fired up. So here's what happened. A former fintech engineer basically wrote this exhaustive breakdown after watching Valve and itch.io get strong-armed by payment processors into removing certain adult content from their platforms. And you know what's wild? Everyone's immediate reaction was, well, just make your own payment processor or switch to an adult-friendly one. This article explains why that's basically impossible. The author really knows their stuff here. They worked in fintech, and they're explaining that becoming your own payment processor means becoming what's called a merchant service provider, or MSP. And the requirements? They're absolutely insane. We're talking millions of dollars in capital just to get started. Regulatory compliance that would make your head spin. And you'd still have to deal directly with Visa and MasterCard, who, surprise, surprise, are the ones making these content rules in the first place. Here's the thing that really gets me. Even Valve, with all their Steam money, couldn't push back against this. itch.io had it even worse. They had to temporarily pull all their mature and adult content just to sort through their entire library and figure out what was acceptable. Can you imagine? You're running a platform for indie game developers, and suddenly you have to become the content police because some payment processor decided that they know better than you do what your customers should be allowed to buy. And get this, if you do try to use one of those adult content-friendly processors, they charge 10 to 15% transaction fees. Compare that to Stripe's 2.9%. Plus, they often require what's called a rolling reserve, where they just hold on to 10 to 30% of your revenue for 6 months as collateral. So not only are you paying 5 times the normal rate, but they're also sitting on a chunk of your money indefinitely. The author really doesn't mince words here. They straight up say Visa and MasterCard have an insane chokehold on the online marketplace. And when you think about it, they're right. These companies can essentially destroy any online business by cutting off their ability to accept payments. That's an incredible amount of power for private companies to have. Now, the Hacker News discussion on this got really interesting. People were throwing around all sorts of potential solutions. A lot of folks were pointing to government-backed systems like Brazil's PIX or India's UPI as examples of how to bypass the traditional card networks entirely. These systems let people transfer money directly between bank accounts without going through Visa or MasterCard at all. And you know what? They work great in those countries. The question is whether something like that could ever happen in the US, given how entrenched the current system is. Of course, crypto came up, because it always does in these discussions. But there was this really thoughtful debate about whether crypto's problems are just cultural baggage from all the scams and speculation, or if there are legitimate technical and adoption issues that make it unsuitable. One commenter made a really good point. They said the article blames capitalism for this problem while simultaneously rejecting the most capitalist solution, which would be competing currencies and payment systems. Actually, there was this one contrarian view that caught my attention. Someone argued that in 2025, building what's called a PayFac, a payment facilitator, isn't actually as hard as the article makes it sound. But even they admitted it wouldn't solve the core problem because at the end of the day, the processors are still the ones making risk decisions about what they'll allow. What really strikes me about this whole situation is how we've essentially allowed financial institutions to become the moral arbiters of the internet. They're not elected, they're not accountable to anyone except their shareholders, but they get to decide what kinds of businesses can operate online. And this isn't just adult content. This affects all sorts of industries that get labeled as high risk. The author points out something that I think a lot of people don't realize. When you're a small platform like itch.io, you don't have leverage. You can't negotiate. You either comply with whatever demands the payment processors make, or you go out of business. It's that simple. And even when you're as big as Valve, you still end up having to comply eventually. This whole story really highlights how fragile the infrastructure of online commerce actually is. We like to think of the internet as this decentralized, freedom-enabling technology. But when it comes to actually exchanging money, we're all beholden to a handful of companies that can dictate terms to entire industries. It's a sobering reminder that technical solutions aren't always enough when you're dealing with entrenched financial and regulatory systems.